but I really didn't need it.
Bicycle shop plans offer two specially priced standard model as a sidewalk sale. The basic model will return a profit of 100, the deluxe model 130. Past experience indicates that the sales of the basic model will have a mean of 5.95 with a standard deviation of 1.1, and the sales of the deluxe model have a mean of 3.65 and the standard deviation of 0.8. The cost of setting up for the sidewalk is 400.
Good. What varies? I want to define my random variable. Good. So B is the number of basic bicycles I sell. What varies is the number of bicycles I sell. And B is the number of deluxe bicycles. That's what varies. It's the number of bicycles I sell, the B and the D model. And my profit, well, I get $100 of profit for the basic, right? So for every basic bicycle I sell, I make $100. And how much money do I make for every deluxe bicycle I sell?
100.
So that's 180 times B, but that doesn't factor in the fixed cost.
130.
The fixed cost is setting up the sidewalks thing is $400. Okay? So my profit is going to be 100 times the number of basic bicycles I sell, plus 180 times the number of deluxe bicycles I sell, minus the cost of actually setting up the
It's
whole.
130.
Oh, it's 130? Oh, 130. Sorry, thank you. Okay. All right. So the answer, I guess, would be B. Right? B, no, C. Sorry, C. Okay. What is the expected profit? 2B. What is the mean profit? So the expected profit is 100. It's the expectation. I'm not going to skip steps. Sorry. The expectation of 100 B plus 130 D minus 400, which is equal to 100 times the expectation of D plus 130 times the expectation of D plus the expectation of negative 400. All right, this is annoying. Okay, so it's 100 times, I expect to sell 5.9 basic bicycles plus 130 times 3.6 minus 4. Okay. Great. Anyone have a fancy calculator to do this with?
I gave you mine.
I return. It's what? $658. So that's your expected profit, $658. Any questions? All right. They asked for the standard deviation, but I am not going to calculate the standard deviation. I'm going to calculate the variance. Why?
Because we can find standard deviation.
Right. You always, whenever you want to calculate, whenever they ask you to calculate the variance, the standard deviation, you always calculate the variance first, and it's much easier to work with the variance. So you never calculate the standard deviation directly. You're asking the question C, part C. For the standard deviation, I don't calculate it. I first calculate the variance, and only after I calculate the variance do I calculate the standard deviation. All right, so the variance of the profit is the variance of 100D plus 130D minus 400. Okay? And this is equal to the variance of 100D plus the variance of 130D plus the variance of negative 400. Okay, can someone tell me, what is the variance of 100 times b equal to? Good. It's 100 squared times the variance of b plus. Good. So far you've done. Now there's another tricky question. What is the variability of negative 400?
0.
0. Good, because it's fixed. All right, so let's keep on going. There's a lot of tricky things here. 1, 2, 3, 4 zeros. Okay. 1, 2, 3, 4. Okay, that's 10,000. And what is the variance of b? What's the variability of basic explosive? It is 1.1 squared plus 130 squared times 0.8 squared, right? The standard deviation for deluxe. So there's a lot of little annoying things here to calculate. Does anyone tell me what it is, or right, whatever it is? I don't know. All right, whatever it is. I don't know. All right, what assumptions did you make when you're calculating the expectation and you went to here? You made no assumptions. When you went from here to here, you did make assumptions. Does anyone remember what assumptions we made? What assumption did we make? That the random variable b, this random variable, the random variable b, and the random variable p are independent. So the trials don't influence each other. And that's not necessarily obvious, because maybe someone who wants to buy a deluxe bicycle ends up buying a basic bicycle. So then maybe they do influence each other. But we're saying none of the deluxe people, they don't influence each other. Whether someone buys a deluxe or a basic are completely independent. All right. 32. Any questions so far?
What was D?
Okay. Did you make any assumptions in calculating the mean? The answer is no. No. Did you make any assumptions in calculating the standard deviation? Yes. The variables must be 32. An insurance company estimates that it can make an annual profit of $250 per policy with a standard deviation per policy of $6,000. Why is the standard deviation so large? And the answer is B. There will be a lot of gains of about $250 with some very large losses. So on average, the profit will be $250, but sometimes they have to pay out a big claim. Maybe they have to pay a homeowner $100,000 because his house burnt down. So generally, they'll just they'll collect the premium and they'll pay the homeowner nothing. But occasionally, they'll have to pay the homeowner a lot of money. Very rarely. Very rarely. These are adult insurance. It was actually interesting. We had a claim on our property, and the insurance company didn't want to pay it, so we sued them. And it was very hard to find case law to sue them, and then they actually did find case law, and we won. But I learned that they actually very rarely, they don't like to litigate the claims because they don't want to have case law on the books. So the insurance companies like to settle, so basically everything is sort of in the dark. There's almost no, if you sue the insurance company, there's usually very little case law. They don't want there to be precedents. Which is part of the reason why I think they settled, is because they didn't want there to be a precedent on the books that another policy would use. It was an interesting case. All right, question B. If a company writes 5 of these policies, what is the mean and standard deviation? Okay. What's the first thing you should do for question B? It's not make a picture, it is define your random variables. I'm going to define my random variables as X. X1 is the profit is actually the profit on policyholder 1. And x2, and I'm going to define x3 and x4 and x5. It's the profit on each single policyholder. So there's 5 policyholders. All right, so an average, we want to know the average of x1 of the 5 policies. The average profits on x1 plus x2 plus the 3rd policy plus the 4th. So we're going to do simply equal to the average of the first, yes, plus the average of the second. Okay, this is equal to 250 plus 250 plus 250 plus 250, which is equal to 1,250. All right. They ask in question B for the standard deviation, but we don't calculate the standard deviation. What do we calculate?
Variance.
So the variance of x1 plus x5, this has some really nice properties. This is equal to the variance of x1 plus the variance of x2 plus the variance of x3. That's not true of the standard deviation, but it is true of the variance. So it has these really nice properties. So this is equal to, it's equal to 6,000 squared, equal to, right, plus 6,000 squared plus, okay, so whatever that is, so 6,000 squared times 5.
That's a lot of calculation.
Okay, that's the variance. They're not asked for the variance, they ask for it. So then when you're done with this, you take the square root. Okay. But again, when they ask you to calculate the standard deviation, you calculate the variance, and then you work backwards to calculate the standard deviation. All right, 10,000 policies. So for 5 policies, the average was 250 times 5, right? That was the average profit for 5 policies. What do you think the average profit is for 10,000 policies? It's going to be 250 times the 10,000 policies they write. And so they're expecting to make a lot of money, right? Okay, so that's going to be, let's just do this, 2500123. So they're expecting to make 2,500,000. Okay. All right. So the variance on 5 policies was 6,000 squared plus 6,000 squared plus 6,000 squared plus 6,000 squared plus 6,000 squared. So, or 5 times 6,000 squared. What do you think the variability is on 10,000 policies? It's going to be 6,000 squared times 10,000. Or if you do it, it's 36, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So it's about, I think, 360 billion? Something like that? And then the square root, so the standard deviation is the square root of that. I think it's about 60 million. Yeah.
So the mean is 2.5 million?
What?
The mean is 2.5 million?
Did I do that right? I think so. 2.5 million. And I think the standard deviation is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know, what's the standard deviation? What is it? It's 6 million. Is it 6 million or 600,000?
600,000.
Yeah. Okay, so it's 600,000. Okay. So the expected profit is 2.5 million, and the expected standard deviation is 600,000. All right. They made it easier. Question used to be hard. All right, next question. Okay, can someone please read this question?
Cognitor finds that she waits an average 20.7 seconds of each of the 5 stoplights, with a standard deviation of 9.4 seconds for the mean of the standard deviation of the total amount of the time she waits for all 5 lights.
Good. So I'm going to be a little bit lazy here because I'm getting tired, so you'll have to excuse me. So we have, how many experiments are there in this example? How many trials are there?
5.
5, right? And so there's basically 5 trials. So there's 5 trials. So the average of the 5 trials is basically, all you need to do is you're going to add up. It's going to be 12.7 plus 12.7 plus 12.7 plus 12.7 plus 12.7, the end. Okay, because there's 5 trials. Make sense? All right. What is the variance of these 5 trials? The variance also has the same properties. It's going to be the 9.4 squared, the variance of the first trial, plus 9.4 squared plus squared plus 9.4 squared plus 9.4 squared. Okay, the end. Okay, and then that doesn't answer. The standard deviation then is the square root of this thing, the radical, whatever that's it. Okay. Okay. Did you make any assumptions in calculating the mean?
No.
No. Did you make assumptions in calculating the variance?
Yes.
Yes. You assume that the trials are independent. Next. Can we move on? All right. Getting tired. All right. I'm going to do the same stuff in here. You buy 8 dozen broken. You buy 8 dozen eggs. I'm tired. So you buy 8 dozen eggs. How many trials are there? You have 8 trials. All right. So now you want to calculate the average of the 8 trials. The average of the 8 trials. So what is it going to be? And the average number of broken eggs per trial is 0.7. So it's going to be 0.7 plus 0.7 plus 0.7 plus 0.7 plus blah blah blah, or 8 times 0.7, or 0.56. They ask the standard deviation of this thing. You don't calculate the standard deviation, you calculate the variance. Okay, so the variance of the 8 trials, it also has these really nice properties. It's going to be 0.4 squared plus 0.4 squared plus. Good, thank you. So that's 0.4 squared times 8, or 0.16 times 8, or 1.28. Okay. What assumptions did you make? In calculating the average, you made? No assumptions. When calculating the variance, you assumed?
Independent.
Good. And also, you need to take the square root of that thing. All right, 29. Someone else, please. I'm asking you politely, please. Someone read the question.
You play 2 games against the same opponent. The probability you win the first game is 0.5. If you win the first game, the probability you also win the second is 0.3. If you lose the first game, the probability that you win the second is 0.2. Okay, part A.
All right, there's a lot of different ways you can do this, but I'm just going to be as lazy as possible. All right, first of all, are the games independent?
No.
Why are they not independent?
Because the outcome of the second one.
Good, say it louder.
The outcome of the second game depends on the outcome of the first game.
Good. Whether your chances of winning the second game are influenced by what happened in the first game. So they do influence each other. So the trials are indeed independent. Okay, I'm going to be lazy, and I'm going to write here, this is a probability model table. one side of the probability model is the outcome, the other one is the probability. Okay. What is the probability if you play, okay, B, what's the probability you lose both games? So the probability you lose the first game is?
0.5.
So 0.5 is the probability you lose the first game. And if you lose the first, what's the probability you also lose the second? If you lose the first, the probability you win the second is 0.2.
Point
So,
eight.
so if you lose the first, the probability you lose the second is?
0.8.
So it's going to be 0.5 times
0.8.
0.8 or 0.4. What is the probability you win 2 games? The probability you win the first game is
0.5.
0.5.
0.5. And it says here,
0.3.
if you win the first game, the probability you also win the second is
0.3.
0.3. So it's 0.5. It's the AND rule, also known as the multiplication rule. So it's 0.5 times
0.3.
0.3 or 0.15. Okay, so there's 3 possible outcomes. I either win 0 games, 1 game, or 2 games. So these probabilities have to add up to? These probabilities have to add up to?
1.
1. So this is 0.4, that's 0.15. This has to be
0.45.
0.45. Yes, thank you. All right. Okay, so here's your probability model, blah, blah, blah. They want you to fill this out. We did it already. All right, they want you to calculate the expectation and the standard deviation. But we never calculate the standard deviation. We always calculate the
Variance.
variance. All right, so the trick to do this is to make a picture. Okay, this is a picture. It'll look like this. This is going to be your outcome. And this is not going to be your z-score. Does anyone remember what this is going to be? Your distance squared from the
Mean.
mean. And this is going to be probability. Okay, I'm obsessed with these bar graphs. I really like them. I think it makes this stuff easy. All right, so what are the possible outcomes? Either 0, 1, or 2. Okay, and what's the probability of 0? It is 0.4. The probability of 1 is?
145.
Okay, and the probability of 2 is 0.15. Now, the average outcome, we want to take the average outcome. So how do we take the average outcome from this picture? It's going to be, the weighted average is 0 times, the weighted average is 0 times 0.4 plus,
1 times 0.45.
okay, and 2 times 0.15, so we get here 0.75. Okay. Let me just make it in blue. Alright, that's the beginning. Okay, so the average outcome is, okay, so now we calculated the average outcome. Anyone lost so far? Alright, the variance. Because we made a picture, this question will be easy. Without this picture, I think they'll struggle. What's the distance squared 0 is from the mean? Good. Or we can ignore the negative, we'll just call it 0.75 squared. So technically you're right, it's negative 1/7. But we're squaring it, so it's irrelevant. How far, what's the distance squared of 1 is from the mean?
0.25.
Okay, so that's 0.25 squared. And how far is 2 away from the mean?
1.20. Oh,
1.25 squared. That's the distance squared it is from the mean. Anyone lost so far? Now we want to take the average distance squared from the mean. The average distance squared from the mean, that's also known as the variance. The average distance squared from the mean, otherwise known as the variance, well, we're just going to use the same technology. It's going to be 0.75 squared. This, and what weight did we assign to it?
4 squared.
0.4. Plus, we're going to take the weighted average, plus 0.25 squared times 0.45 plus 1.25 squared times 0. Boom, you're done.
Professor, we are not 0.75 squared times 0.4, just 0.4, not squared? Because
No.
there was a problem we
So
did like
here,
square.
you're taking, when you took the average outcome, you took 0 times 0.4, 1 times 0.45, 2 times, you're doing the same thing here, you're taking 0.75 squared times 0.4. 0.25 squared times 0.45, 1.25 squared times 0.15, right? And that gives you, that's not the answer, that gives you the variance. So now that you have the variance, right, that's the average distance squared from the mean. Then you just put a square root, you take the radical, a square root, whatever you want to call it, and blah, 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 you have the standard deviation. How do you answer the question? You make a picture. That's the picture you want to make. Make a picture, it's easy. All right, let's do this. We're going to do the same thing. This question, let's make a picture. Let's do this fast. All right, we have the outcome, the distance squared from the mean, and the probability. Okay, so we have here 15 is one outcome, 25, 35, and 45. Okay, and this is 0.2, this is 0.3, this is 0.4, and this is 0.1. Okay, so how do I find the average outcome? I want to take the average outcome. It's going to be, someone tell me, what do I do?
15 times 0.2.
15 times 0.2 plus
25 times 0.3.
25 times 0.3 and 35 times 0.4, 45 times 0.1. This is 3. That is 3, 6, 7.5. That is 12. That's 12. That's 14. And that's 4.5. Okay, so that's 12. That's 26. That's 29. Okay, let's assume I'm ready. All right, so the average is here. The average is 29. That's the median, I think. What's the distance squared 15 is from the mean? 14 squared. So it's 14 squared, 196. This is?
4 squared.
4 squared. Good. How far is 35 away from the mean?
6 squared.
6 squared, and that is 16 squared. Okay, now how do I calculate the variance? So the average, I want to calculate the average distance squared from the mean. The average distance squared from the mean has a fancy name, that's called the
Variance.
That's the same thing as calculating the variance. Okay, so I want to calculate the variance, so it's going to be 14 squared times 0.2 plus 4 squared times 0.3 plus 6 squared times 0.4 plus 16 squared times 0.1. Okay, just make the picture and you're golden. Any questions? All right, let's do this. I'm getting tired. I'm sure you're exhausted. All right, let's take a break, and Mr. the Maestro is going to entertain us for 2 minutes. I need a break as well.
I am again? All right.
He's ready.
Wasn't expecting it.
It's like falling asleep.
I'm exhausted, so we're all tired. So we need a break.
You know what? Okay.
All right. To the,
You gonna pause the video? Yo. Are you gonna pause the video? I don't know how.
We have the same laptop.
I just got it. I'm new
No,
today.
no, no.
Just go to the.
You need a password?
Oh, yeah. I need a... Got something.